Today in this lesson, we're going to talk about experimental design and values. So the objective for this lesson is that you will learn how to design an experiment and analyze the data that you collect using tables and graphs. Make sure that you use your hypothesis as an educated guess about what you think may happen in the experiment. And you're going to use that if blank, then blank format where you can predict that experimental outcome. So remember that your if blank is your independent variable that you're going to change. And the then blank is the dependent variable or what you expect to happen as a result of the independent variable. So one of the first things you'll need to do after you have your hypothesis is to choose the materials that you will use in this experiment. So you're going to make a list of everything you will use. You'll include each piece of lab equipment that you need, and you need to be specific. If you need a beaker, you need to say how big of a beaker. Do you need a 250 milliliter beaker, or do you need a big 1,000 milliliter beaker? Then you also want to make sure that you say how many of each item is needed. So again, be specific. If you only need one beaker, then you say one 250 milliliter beaker. But if you need four, then you include that. And you're always going to use metric measurements whenever you use when you write your materials. The next thing is your procedure. So when you start to write your steps, you want to think about this design so that you're only testing for one thing. You only want one independent variable, because if you have more than one, you're not going to necessarily know what is deciding your result. So you want to keep it to just one thing that you've changed, one independent variable. And then you need to decide what's going to serve as your control. What's the normal conditions that can give you something to compare your experimental results back to. And then the last thing for this step is decide what constants you will have. So if you have your independent variable that you change, what are going to be the things that will stay constant in every other aspect of this procedure or this experiment? For this procedure, you want to make sure that you write these steps down individually, step by step, so that you don't forget anything. And that way, if someone else comes behind you, they could do the same exact experiment exactly as you did it. And be sure to include at least 3 trials. You can do more, but at least 3. And remember, trials are just repetitions so that you have data that you can average in case there was some little glitch in one little piece of one of your trials. As you complete the experiment, you want to think about your data. Are you going to collect qualitative data, which is going to be descriptive, like wilted, or maybe a color, a yellow, if we're talking about leaves, yellow leaf or green leaf, right? Or are you going to collect quantitative data, which, if you can hear the word quantity in there, this is going to be a numerical value, like growth in centimeters or number of leaves that grew in a particular amount of time. Decide how you want to record that data. And so you typically will use a table in this step. And then you need to figure out how often to collect data, and that will help you set up your table for how many blocks you need across the top and how many you need down the side. Then you want to collect, record, and display your data. So when you record it, you're going to probably use a table to actually write it down. It's always good to take pictures as you go, because the pictures can help you show early, middle, and late results. And then you need to choose what kind of graph you're going to use for your data. So you can use a bar, a pie, or a line graph. So these types of graphs have different uses. So if you are going to compare categories, let's say you had, and I'm making this up, blue birds, green birds, orange birds, and pink birds, the color can be a category. So a bar graph would be good here. If you're looking at percentages of the whole, then this is where you might have, let's say, who eats lunch in the cafeteria going through the line. Who brings their lunch? What percentage of that whole population brings their lunch? And then who just snacks on something from a friend? So that might be 3 examples where you would have different percentages, but altogether it would add up to the 100%. And then a line graph is where you will use, you will have some time component. So you're going to measure, let's say, growth over a period of so many hours or however many days or weeks that you set your experiment up for. So they each have their own purpose. And then finally, you're going to conclude, and this is where you explain the outcome of the experiment. And when you explain this, you're going to explain the results by including your hypothesis, whether or not it was supported. And this, you will also include your independent variable that you changed, that you were actually testing, and your dependent variable, which is your data that you collected, to help explain those results. And if your hypothesis was not supported, then this is where you're going to change your hypothesis, or you can change your experimental design and then repeat the experiment. Make sure that you complete your notes and get ready to go to the next task.